two of the three methods of solving systems we learned by graphing on Thursday of last week, and you learned that you're looking for, in a system, you're looking for where the two lines intersect. So you're looking for the point of intersection, so you must always write down the point for your full solution. Unless, of course, it's no solution if the lines are parallel, or infinitely many solutions if the lines are the same. So those are the important things to remember. Substitution, we learned we had to isolate a variable, right? And when we isolated that variable, we could then sub it into the other equation, the expression in, and go from there. Today we're going to talk about elimination. I've noticed that kids tend to think this is easier than substitution, but I mean, obviously there's a few of you that will not agree with that. So if you need help, please let me know. So let's start with the first one. So this situation is if you have opposite coefficients on a variable to start. So what do I mean by that? So because this is the big thing you're going to want to do. What does elimination sound like to you? When you hear the word elimination, what do you think? Yeah.
You get rid of it.
You're getting rid of something. So you're eliminating something. So one of the things with elimination is that your equations need to be in standard form, which is that ax plus by equals c. So you have to have both of your equations in standard form. So both equations must be in standard form. Let's just write a note here. That's at ax plus by equals c with x's lined up and y's lined up. So if it's like a and b, so if I don't give you x and y, if it's a and b, you want your a's lined up and your b's lined up. So notice your x's are lined up here, your y's are lined up there. If it was like M and N, you'd want your M's lined up and your N's lined up. So if they're not lined up correctly, make sure you get them that way first. So as Hannah has stated, elimination sounds like you are trying to get rid of something. So this is why it's important to have opposites. Because if I add -2 plus 2, what do I get? 0. It eliminates the 2's, right? So you want the opposite numbers. So if you notice here, are 3 and 2 opposites of each other? Are -5 and 5 opposites of each other? So what you're looking for is in front of the coefficient, and we'll talk about what to do if this isn't the case, in front of the variable, the coefficients are opposite. So in this case, we can eliminate the y's because they are opposite. So to do that, we're going to combine the systems by combining like terms. So that means you're going to add the systems together. So add the systems together. We're going to put a big addition sign here. So if I add them together, what's 3x plus 2x? Do you understand why your x's need to be lined up and your y's need to be lined up now? If I do -5 plus 5y, what do I get? So that's plus 0. And then if I do -16 plus 31, what is that? What is that? 15. So notice you now only have one variable in an equation that you can solve. So now you're going to solve for the variable that remains. So we have 5x equals 15. So Alex, how would I solve for that? Good. And then plug back into one of the equations to find your other solution. Remember, x isn't your only solution. You're looking for where these two lines intersect, so it's an ordered pair. So Morel, how would I find the other variable?
Plug 3 in for x.
Which equation?
The second one.
You want to do the second one? So we're going to use the second equation and plug 3 in for x. So y equals 5. So the last thing you're going to do is list your solution as an ordered pair, always in alphabetical order. So 3, 5. So if you do not have x and y, then you must use alphabetical order there. So look at that. That one's the easiest of all the methods of elimination. Look at that and see if you have questions for me before we move on to another example. See what questions you have. All right, so again, both equations need to be in standard form. So that means that it's ax plus by equals c. Are these both in standard form for elimination? Yes. And this time we don't have x and y, we have s and t. So when we do our ordered pair, it's going to be s comma t because that's alphabetical. Now, this situation is if the coefficient is the same in front of a variable, but not opposite. So if you have a system that contains terms that would cancel if they would be opposite, it says multiply one of the equations by -1. Why would multiplying one of the equations by -1 help you? Why does that make sense? Iris?
It would change the signs.
It would change all the signs, making the ones that are the same. So these 2's are both positive, right? So these aren't the ones that are the same, right? The numbers in front of the coefficients in front of s are not the same, but the coefficients in front of t are both 2. So if we multiply one of the equations, it doesn't matter which one of these 2's is going to become negative, making it opposite. Be careful to multiply all pieces. So we're multiplying by -1. So I multiply this by -1, this by -1, and the number after the equal sign. If you do not multiply all of them, you are not making an equivalent equation. So I get -5s minus 2t equals -6. And underneath that, I get 9s plus 2t equals 22. So I just rewrote the second equation. I didn't change it. I'm making sure that the s's are lined up with the s's and the t's are lined up with the t's. They're in standard form, so we're good there. Now can we add them together? Do we have opposite coefficients? So once you have opposite coefficients, you can add them together. -5 plus 9 is 4, so that's 4s. -2 plus 2 is 0. -6 plus 22. Okay, so now I'm down to one variable, making it solvable instead of having the 2 in there. Kaylin, how would I solve this? Carly, what do I still need to do? Which equation do you want to plug it into? Which, it doesn't matter. Which one do you want to do? Okay. You will get the same answer either way, so. So T equals -7. And again, ordered pairs are always in alphabetical order, so S comes before T in the alphabet. If you need to sing the alphabet to yourself, it's okay. But make sure you're putting them in alphabetical order. All right, look at that one. Finish copying it down and see what you have for me. All right, so the next one is, does anybody need me to go back? Are we good? Okay. In this case is, the coefficient isn't the same at all. Coefficients in front of the variables are not the same at all. So if the coefficients, if you have a system that contains terms do not cancel at all, so the coefficients are not the same, they're not opposites, determine by what number you can multiply one or both of the equations to make them cancel out. So look at this problem here. We have 3a plus 4b equals 6, and 5a plus 2b equals 4. So what I always ask myself is it easy to make the smaller number turn into the bigger number? So is it easy to make 3 turn into 5 by multiplying it by something? No. Is it easy to make 2 multiply by something to make it 4? So what could you multiply 2 by to make it 4? Now I have a problem with just multiplying that bottom equation by 2. Why is it a problem just to multiply it by 2? Jill?
Because 4 and 2 cancel each other out because
They would both be positive. So look at that again. Everybody look up here. Make sure you're paying attention. We have 2 here. If I just multiply it by 2, right, this is a positive 4 and that's a positive 4. So adding them together will not cancel it out. But as Alexis just said, if you multiply it by -2 on the bottom, that's a -4 and a positive 4. So if you add them together, it will cancel out. So -2 looks like our best option in this case. So we will multiply all pieces in the bottom equation by -2, including after the equal sign. Make sure you're including after the equal sign. So that's -10a minus 4b equals 8. Always take the sign that's in front of the number, so that's positive, positive, negative, so that's why it ended up that way. Bless you. And then I need to line up my variables. So a needs to line up with a, b needs to line up with b, and the constant needs to line up with the constant. So I just rewrote this equation, making sure that my variables are lined up, that are the same. So when I add them, I'm actually adding like terms. So now can I add the 2 equations together? Are we good there? All right, so let's add them together. -10 plus 3 is 7a. That becomes 0. 8 plus 6 is 14. So I have 7a equals 14. Sarah? Thank you. Thank you for telling me before we got to the end of the problem and the whole answer was wrong. Okay, Jacqueline, how would I solve for a? Not yet. There you go. So a equals -2. So Madison, then what? So I plug a in there to get b. This is for next hour. Just make sure you show your next hour teacher, okay? So B equals 3. So give me the correct ordered pair, Jenny. How would we write this ordered pair? Good. Always in alphabetical order. All right. So look at that there. See if you have any questions for me before we move on to the next slide. Jenny, did you already do your problems too then, and have the same issue as Hannah?
I didn't.
You didn't finish it, okay. So did you already submit it?
Yeah.
Okay. I'm just making notes. All right, are there any questions on that before we move on? Okay, then the last one is the same kind of situation. If you cannot make terms cancel by multiplying just one of the equations, try multiplying both of them. So looking at the smaller number, is it easy to make 6 be 8? Is it easy for 3 to be 4? And you're not dividing ever, you're always multiplying. So please do not think about this as division. So we have them in standard form in the sense that it's ax plus by equals c, just with n's and p's, which is fine. So that's good. Our variables are lined up, but we're not going to be able to just multiply one of them. So we need to change the equation so that one of these cancels out. It doesn't matter which one. So do you rather change 8 and 6 or 4 and 3? Kelly?
4 and 3.
Okay, what is a number that 4 and 3 both go into when you multiply? So when you multiply 4 and 3, both go into the number 12. Do you guys agree with that? So what do you have to multiply 4 by to get it to 12? So if we multiply everything in the top by 3, that will give me 12. So what do we have to multiply everything in the bottom equation by to make 12 for the 3? Yeah. And why did Madison say -4 and not just 4? It's really important that she said -4. Alexis? Yeah, if we do +4, they're both going to be +12, right? That's not going to cancel out. We want one to be positive and one to be negative, so it has to be a -4. So we multiply all pieces by -4. So I get 24n plus 12p equals 30. Then I get -24n minus 12p equals +30, right? Negative and a negative is a positive. So, now that I have opposites, I can add them together. So I get 0 plus 0 equals 60. Does 0 equal 60? So what is my answer then? No solution. So you can still get those infinitely many and no solution cases too. So do we have questions on our different cases for elimination? How many of you find, before we do the word problems, how many of you so far think this seems easier than substitution? Okay, how many of you think substitution still seems easier? Okay, and that's typical. I usually have most people with elimination and a few with substitution. I think when I was in high school, I loved substitution. Now that I'm teaching, I love elimination. So who knows what will happen here. But if you don't understand something, please make sure you come see me. So we're going to do just a couple word problems here, and then I'm going to give you guys your homework. We're going to make sure on your homework tonight you solve by elimination and not by substitution. The homework is by elimination because that's what I taught you today, and I need you to practice that because on the test, you're going to have to show me all the methods and with what I tell you to do, okay? So let's look at the first word problem here. Tickets to Six Flags cost $47 for an adult and $37 for a child. A few families went to Six Flags together. There were 13 total people, and they spent a total of $531. How many adults were in the group, and how many children were in the group? So the first thing you need to do is define your variables. So what am I trying to find? Katie, what am I trying to find? So I'm going to say A is the number of adults, and C is the number of children. Okay, so let's go back through this, and it's not all in one sentence this time, so it's going to be really hard to put the right piece together. But it says that it's $47 for an adult and $37 for a child. Is there anything else that you think goes with that information? Madison? Those are all money, right? The same unit, so those all go together. So that's one equation. Then it says a few families went to Six Flags together. There were a total of 13 people. So that's a separate equation there. Help me write one of the equations. I don't care which one. Anna. So the number of adults plus the number of children that attended Six Flags has to total 13 because that's how many people went, right? Yeah. Do you want to do the other one?
Yeah.
Let me get my red up here. Go ahead.
47K plus 37C.
So it's $47 for an adult ticket, $37 for a child's ticket. If you add those two together, it should give you a total money amount of $531. Okay, so since we learned elimination today, we're going to do elimination. Somebody tell me how we could use elimination here. What could we do? What do you think we could do? Jenny, what could we do?
You can multiply by negative 47 or by negative 30. So.
Yeah, so let's multiply the top equation by negative 47. I don't care which one you do, but that was the first one Jenny said, so that's the only reason I said that. Jacob, what's negative 47 times 13? Can you put it in your calculator? I don't know either. That's why I asked you to put it in your calculator. 481. Okay, and then I line up my A's, my C's. Is that wrong? Yeah, that doesn't. It could be right. It's negative what? Okay, 1 second. So it should be negative 611. Do we agree with that? Has anybody else tried it? If somebody else has tried it, please let me know. But that adds, that way we have our opposites in the A, right? Negative 47 and 47 are opposites, so that cancels. And you said, Sarah, that is correct. Okay. So we add them together, and I get 0 minus 10C equals, is it negative 80? Is that what it is? Somebody tell me. It is negative 80. Okay. So I get negative 10C equals negative 80. So C equals 8. How can I find the number of adults then? And again, if you don't have to plug it back into an equation, you don't have to. I just do this on the notes so that you guys see it. If you guys can do it quickly on the calculator, I'm completely fine with that. But Spencer, how could we find the number of adults? Second equation, do you think that one's easier than the first one? The first one doesn't have any numbers in front, meaning you don't have to multiply. I mean, you could do that, but it's going to be a little bit quicker to do this one. Just for your own time's sake. Help yourself out. So, 5 adults and 8 children went to Six Flags. All right.